everyone. Uh, I am Engineer Naveed Ahmed, and I would like to give you a brief overview for the Unit 1 for the upcoming assessment. Let me start the Unit 1 from the very beginning. Uh, the course name is Soil Mechanics, and the books which we are following in this for this subject is the Principle of Geotechnical Engineering. First of all, before starting the soil mechanics, we should know what is geotechnical engineering. Geo means earth, and the technical, here you can say the geo means what? This is mean earth. Geotechnical engineering is a branch of civil engineering that focus on the behavior of earth material using principle of soil mechanics and rock mechanics to investigate subsurface condition and materials to produce economic and safe geotechnical design. What does it mean? Geotechnical engineering is nothing. It is the practical application in civil engineering of the soil mechanics to design our building safe and economical. So is like how, for example, you're going to design a three-story building, and this is the formation level, this is ground level, and there we have a soil, for example, foundation, and here this is the soil. So if we design the frame structure very well, but if there is a problem with the soil, so what will happen? The building will be settled down. It's mean all, as you know, that all the civil engineering structures, either it is building or it is transportation or any marine structures or any structures, they all are built or constructed on ground. So there or all the loads at the end transfer to the soil. So if the soil is much strong or much having the bearing capacity, so then our building or our structure will sustain. Otherwise, if we design our structure very well, but the soil bearing capacity is not good, so at the end, after some time, our buildings become what? Fail. So that's why geotechnical engineering is one of the most important course for the civil engineering, because as I discussed that all the loads of the building or any civil engineering structures transfer at the end to the soil. If the soil is good, so our building will remain sustained. If it is not good, so it will settle down and our building may be cracked or maybe fall. So that's why we are studying the geotechnical engineering. Why geotechnical engineering? As I discussed, all the civil engineering projects or schemes, it may be road, building bridges, dam, tunnel, and water tanks, and many others, are constructing or in the ground or above the ground. So several foundations related to engineering problem risk could have been avoided if the proper geotechnical engineering study had been done. What does it mean? It's mean if, for example, this is our building and this design, the concrete, the steel reinforcement which is used here, QA and QC, all the things are as per the quality, as per the drawing. The frame structure is very well, but we didn't check the soil under the this building. So what's happened? Our structure is most like more capable to resist the own load, or they have more resist the loads. But what's happened? Like for example, this is a house, and here this is the soil. So now this by its own, it is very strong. Okay, it has the capability to resist, for example, 100 kg. But the soil underneath, under this building, it has very low bearing capacity. So what does it mean? The soil which is under this, so it has very low bearing capacity. So what's happened, for example, I constructed this house. So after some time, this will become what settle down. The building comes under down, so which may produce a cracking or may fall the building at one side or at both sides. So that's why we are studying the geotechnical engineering. Here are some example like we have seen for the Leaning Tower of Pisa. So you can see this. This was the tower. It was before, like so. It was before like this vertical, but the soil underneath it is not of good capacity or good. They have not enough capacity to take this upcoming load. So what's happened? The load is, for example, the capacity is 100 kg and the soil have the capacity of 90 kg. So what will happen? It will what settle for till 90. The soil have the capacity to take the load. But if it is more than 90, so what will happen? It will become the soil become compressed. We will see this in the next chapters. Compressibility. So it's become compressed, which is called settlement. These soils settle for this end. So what's happened? The building it is tilted in this direction. So at first it was I think 5 degree or 7 degrees. So now it is reduced to a certain limit. But still you can see here the building or the structures, beam, column, slab, it is well enough or good enough to resist the gravity or the lateral loads. But the problem here it is with respect to what the soil bearing capacity. The bearing capacity of soil is not enough to resist the upcoming load from the building. Remaining the building is well enough because see the building is at its own position. All the alien or structural element its own position. It is not cracked or not demolished. But the building overall it is tilted. It is tilted because of what the soil under this building. So you can see here this is another one tilting of Girsenda Tower, and this is another example. You can see most of the example. This on the. So now what is soil mechanics? Soil mechanics that study, it is that type of study in which we study about the behavior of soil mechanics or soil under different loading conditions, waters, and some of the environmental conditions. So soil, it is the part of geotechnical engineer. So this is geotechnical engineering. It is the part of what? Sorry, it is the part of geotechnical engineering. It studies engineering mechanics and physical properties of soil. You describe the engineering behaviors, mechanics of soil under different loading conditions and water flow in the soil. All these loads are supported by the soil below. What does it mean? So in this, like this is the building here, you can see this is the substructure before. This is called what superstructure, and this below the ground level is called what substructure. So this is the foundation, and after the foundation, the load is transferred here to the soil. So we check the behavior of soil. This is, for example, soil, and this is the load, upcoming load from the building. So we check or we evaluate or analyze the behavior of this soil under different loading condition. This is gravitational load. Some of the time lateral forces due to the seismic zolzal happens. So we check what is the behavior of these cells when the gravitational loads or the lateral loads happens. So how they react, because we are civil engineers, so we should to check the soil with respect to all types of exceptional or exceptional loads. Maybe it can be gravity. Gravity is always, but some of the time it's happened to the lateral forces as well. So we check either if the lateral forces is happen, so it is still stable or not due to the gravitational. This type of soil is stable or not. How much it has the capacity to take load by the gravity load. So this is all about what in simple you can say soil mechanics is the branch of geotechnical engineering in which we dealing or in which we evaluate the behavior of soil under different loading condition. It may be gravitational or lateral forces. We check the behavior of soils, what happened after the application of load. Does it settle more? Thus, it is permeable more. So we will see these all the things in the upcoming slides. Okay, here are various scientists they contributed for the soil mechanics, but here is one Carl von Terzaghi. Terzaghi, it is also called the father of soil mechanics, so you should to remember this. It may become in your exams or some of the time it will ask in the interview as well. So Colles columns, Rankine theory, Casagrande, we will see inshallah this in the next few slides, Mirhoff and Septon. So these are the different scientists, they are worked on soil mechanics, on different behaviors, on different innovations. So soil mechanics, the Targhabi was the scientist, which is also known as by the name of father of soil mechanics. No, we are going towards the very important topic, which is called the soil origin of soils. Origin means from where the soil comes. Like, for example, if someone is from the Jeddah and he is living in the Riyadh. So if someone asks you where is your origin, so your main origin from where you belonged, it is Jeddah, but currently you are living in Riyadh. So your origin is Jeddah. So here we are talking about the origin of different soil. Soil is turba. Soil is a loose material considered of solid particle. What is mean by loose material? Loose materials like these are the particles. Pay attention, this one particle, it is called what? Some of the time grain. Also, it is called what? Particle. And some of the time it is also called sediment. Or some of the time it is also called single element. So whenever you heard this word, so you should know that it means the individual single particle or single element of the soil. So soil is a loose material consisting of solid particles. There are two types of soils: organic decompositions and another one is weathering of rocks. Organic decomposition means the decomposition of soil by two. It may be by the plantation or it may be due to the animals. What does it mean? Like, for example, thousands of years ago, if there was a tree and it is broke down at that time, so it is mixed with of soil and that make soil. So that type of soil which is made from the plantation is called what? Organic soil. Or some animals which are died and buried in the soil. So the organs of the animal is mixed with that soil. So that type of also called is called what? Organic decomposition or organic soil. The another one is weathering or frog. Weathering is means what? The disintegration or break down of rock, big rock, into small particles due to mechanical or chemical agents. So what does it mean? We will see this in detail in the next slide. Before that, the process of formation of soil is called what? Pedogenesis, means soil formation. So you should remember this word. It is formed by the weathering of rocks. Note, weathering signifies the disintegration of rock. What does it mean? This is the big rock. What is mean by weathering? Like this is the river which is close with this rock. So when the water is moved here and heat this portion of the rock, it is heated most of the time. So several times, in most of the time in geotechnical or geology, when we talk about the time, so it is in millions of years, million or thousand of years. So after some time, this is called erosion. What is erosion? This is rock and the water come here at this portion. So this portion become loose. So the particles move with the water. So these particles which flow with the water. So this is called what? The process is called erosion or weathering. So I think you got this point. The big rock, it is converted to a small rock by the flowing or heating of water to this specific position. So after several times or after long time, this portion is disintegrated or divided into small particles. So now this process is called pedogenesis, and the process of formation of soil is called pedogenesis, and this process is called also what, weathering or erosions. So there are different type of weatherings. So we will see in detail one by one. The first one is, for example, mechanical. Mechanical weathering. It is the weathering which is the breakdown of big rock. This is big rock, jebel, into small particles or small pieces without changing their chemical composition. What does it mean? For example, if the parent rock it is made of silica, so the weathering occur due to the Hawa, due to the glacier, or due to the water. So when it is converted to the small particles, also when we check their chemical composition, it is still what? Silica. Their chemical composition is not changed, it is remain as it is parent rock, like sand and gravel. You can see here sand and gravel. Same for the chemical. For the chemical, we can say what, the transformation of rock into one or more new compounds, decompositions. For example, this is a big rock. Okay, you can see this picture. This is the igneous rock. So what is igneous rock? Igneous rock we will discuss in the next slide in very detail. The rock which make from the eruption of magma. When it is come to the ground, so it is called lava. So after some time, this lava become cool down. So when it's cool down, so its temperature decrease. When temperature decrease, so it's converted from liquid to the solid. So now this rock is called what? Igneous rock. So now weathering occurs due to physical or chemical. So the physical means what? The chemical composition is still remains same, but in the chemical, the chemical composition is what change. It is not same, like it is made of silica. Here you can see it is made of silica. In the physical, same, the small particle is made of silica, but in the another one, if the bigger one is made of silica, maybe due to the weathering there is another material or another substances molecules present in the water, so it changes the silica to another compound or material. So it is called what, the chemical composition, sorry, chemical. Now there is a soil formation cycle. What does it mean? There is a cycle for the soil formation. First, you can see this is the rock. This is rock. Weathering occur due to Hawa, due to water, or due to any agent. So it is converted to the small particles. For example, there is a river with this mountain or jebel. So when the waters come and hit this portion, so it will convert the big rocks into small particles. So the small particles is transported with the water. So when it is transported to the water, for example, this is the water. So water move here at this portion, it is very fast because there is a slope. So the velocity of water is more. Now here you can see, for example, here the slope is less. When the slope is less, the velocity also less, or the speed of the water is less. So here what's happen, from here the soils move very fast, but here you can see the slope is less. When the slope is less, so the velocity is less. When the velocity is less, so it's mean the particle is decomposed here. Jama mean it is layer by layer store here. So after some time, so it is called deposition. Together, all the particles together, so it's again make what, upheaval. Upheaval means it's make again what, like a rock. So again, if some airs or waters come to this one, so it will again do weathering, and the weathering do transportation, transportation deposition, and upheaval. So this is the cycle. You can see your weathering, then transportation, then decomposition, and then upheaval. So there are the definitions given to you. What is weathering? Weathering is the breakdown of large particle into small particle due to any agent, due to wind, due to water or temperature changes. For example, This is a granite rock surface breaking into sand and clay. This transportation, what does it mean? Transportation, a weather particle, the particle which is converted from big to small, like sand, clay, and gravels, carried away by a natural agent, by Hawa, glacier, or any other agent. Depositions mean, what does mean by deposition? The transported particles settle down when carrying energy decreases. As I see, like this is the slope. So here the transportation energy or power, it is more because it is slope. So here the slope is decreased. When the slope is decreased, the velocity or the speed of the water also decrease. When the velocity decrease, so what's happened? The particle of soil become upheaval, or sorry, decomposite here. So it is called then upheaval means deposited layer may later be uplifted by geotechnical geological forces and exposed to the surface again. So it is not like a 1 day or 1 year or 10 years process. It will happens in million of years or thousand of years. So this is a very simple graph. You may understand inshallah very easily from this. So this is rock. Okay. What's happened to this rock, for example, due to wind or water or any other natural agents, it is heated for the large time. So what's happened? This big rock is converted to a small particles. So now these small particles is transported by water, by mean of water or by mean of air. So this is this transportation force. So when it is transported here you can see the slope is very high. So the slope is high means the velocity or the speed is high. So the particles can move very speedily. So now you can see here at this position, the particles or the slope is decreased. So now what's happened? This particle is jama layer by layer decomposited in this position. So now the velocity is low here. So the velocity is low here means the particle movement is less. So all the particles are jama here. So after some time you can say it is again make what? Upheaval. So now this is again exposed to the weathering. So after some time weathering again. So it is transportation, decomposition, and then composition, upheaval. So this is called what? The soil formation cycle. Now there are some types of soil formations. So the first one is residual soil. So the soil that remain at the place where it was formed directly from the weathering of underlying parent rock. What does mean? This is the rock. Okay. So weathering happens. Due to the weathering, the particle is converted into the small particles. So the particles still remain its own position, or it's the same rock. It is not transported. The particles remain at the same rock. It is not transported. So this type of particle or soil is called what? Residual soil. So you can see it is not transmitted. The another one is there are two type of soil. Oh, this is sorry. Soil. One is residual, and the another one is transported soil. Transported soil means the first one is mean what? Like this is the rock and disintegrations of the breaking down of the soils happen and the soil is still at its main or parent rock. It is not moved or it is not transported. So it is called residual soil. No, if there is a rock and disintegration of soils happens, the rock is break down into small particles and it is transported from here to there by any mean. By many mean means by any natural agent due to Hawa, due to air, due to wind, or due to glacier, anything. So no, this type of soil is called what? Transported soil, as it is very clear from its name. So you can see that transported by river, stream, very fertile, and layers of sand, silt, clay. Okay, this is what the soil, it has been moved from one place to another place by agent of any of these. So there are no another things. The first one is what? The alluvial soil. What's alluvial soil? Alluvial soils means when these breaking particles moved by mean of water in what, in rivers or in streams, so that type of soil is called what? Alluvial soils. In simple you can say the disintegrated or the small particles are the soils which transported by mean of water is called what? Alluvial soil. The another one is aeolian soil. Aeolian soil means which transported by mean of wind. The another one is glacial or till soils, the soil which is transported by mean of glaciers, and the fourth one is collovial soils, the soil which is transported by mean of gravity, like landslide and fog. So you can see this is the mechanical or physical erosion due to ocean waves and other winds. So it is by mean of winds, and this is the erosion by weathering. The next topic, it is very important, it is the rock soil formation. Rock cycle. It is the rock cycle describe how the rock changes from one type to another naturally over the time through different process like heating, cooling, weathering, and process. So the first one is what, for example, this is the ground level, and these are different stratas. So there is the heat, the lava. Sorry, it is called magma. The magma erupted from here. So here the temperature is about 700 to 1100, I think so, degrees centigrade. It is very hot. So when it's exposed to the ground, so at ground maximum it is 50 to 55 degrees centigrade maximum, like that much. So now when this magma decreases gradually, the temperature decreases. So now it is in the form of liquid, or which is called what? Molten state. Molten state means if you give a temperature to anything like plastic or steel, so it's converted from solid to liquid by mean of what? By mean of heating. So that state is called what? Molten state. So before under the ground or at the beneath of ground, the magma is in the form of molten state or in liquid form. When it is exposed to the natural ground, so now the temperature here it is less, it is 50 to 55 degrees centigrade. So it is converted slowly and gradually from liquid form to the liquid form, then it is from semi-solid form, and at last it is converted to the solid form. So now this rock which is formed by the mean of magma, so this type of rock is called what? Igneous rock. Again, if this igneous rock is subjected to weathering, weathering by mean of any, by mechanical or chemical, maybe hawa, maybe any agent, air, hawa, water. So weathering happens, so it is converted to a small particles again. So now these small particles, like, let me clarify it. This is the igneous rock. Weathering happen due to any means. This, like due to, for example, water. So now this rock is converted to a small particles. Okay. Now these particles decomposite or connect with each other. For example, there is a river or there is a sea. So now these particles come close to each other by mean of water, and it is stay here. So they make a bond with each other. So it is compacted to each other very closely and make a bond with each other. So now this makes layer by layer. For example, this is one layer, another layers and another layers, and these particles are connected with each other with a very strong bond. by mean of any mineral which is present in water or the mineral which is present in the same rock. So they are cemented or get together by these minerals which is present in the water or maybe present in these particles. So these layers, this is make and it is make again a rock. So now this rock is called what? Sedimentary rock. If the sedimentary rock or any rock, it is subject to what? To a heat, okay, and pressure. See, you can see as I discussed before, these are different stratas of the earth. So there is the lava, okay. So here the temperature is maybe 700 to 1100. So no, the area which is close to this layer, to this way through which the soil, through which the magma is passing and exposed to the earth. So along with this, at both sides, this land or this earth is also get at some temperature because here it is, for example, 1100. So as you move here, the temperature is more and more, and as you move to the left or right side, so the temperature become decreases. So the areas which is very close to that way, passing way of the magma, so also their temperature is changed. So if their temperature is changed means their heat is changed, so the behavior or the capacity, or we can say the composition of soil is changed because now it is subjected to a very high temperature, maybe it is 600 or 500. So it is no not a normal rock. So that's rock which is subjected to high temperature and pressure without changing to what? To magma. It is still in solid form, but subjected to a very high temperature and pressure. So their chemical composition is changed. So now this type of soil is called what? Metamorphic rocks. So again, the metamorphic rocks, if it is subjected to a very high temperature, so it is converted from solid to liquid, which is called what? Melting. So it will make again what? Magma. So this is also a type of, or you can say the rock. So I